Thanks. So yes, welcome to our talk, the Sling Feature Model Revealed. This is David Boschert and I'm Karl Pauls. We both work for Adobe and am both actively involved in Apache Sling and Apache Felix and the OSGi Alliance, especially David more than me. And well, I guess for those that don't know what Apache Sling is, Apache Sling is a web framework which is based on top of OSGi. It's around for a little bit over 10 years now, I think the whole thing started about 2, maybe 3 years ago when Carsten Ziegler from Sling started to implement a feature model for Sling. So it's not the feature model that you might be known from from Carafe. So it while it serves a similar purpose, at least in parts, it's not the same thing. So it started in Sling mainly as a way to organize Sling and other things that are based on top of Sling. But by now we're trying to make it part of an official OSGi spec. We will hear about it later. So it is not only Sling specific, hopefully, but it's not Carafe features. So, and again, we started about 3 years ago with a prototype from Carsten. Have evolved it quite a bit since then, and by now we released version 1.0 and 1.x by now, so it is considered somewhat stable and hopefully works. So we figured we might introduce it to a broader audience at EclipseCon now, and so that's what we're going to do today. We're going to first tell you how it all fits together and how it looks like, then talk a little bit about some tools we already have for it, and I will then take over and talk a bit more how we envision and use it ourselves in terms of Docker and practical applications, and give it a little bit of a demo, and then David will explain what the current efforts are around it in the OSGi Alliance. With that, I think we tell you.
Okay. Thanks, Karl, for the introduction. Okay, so let's just talk about building an OSGi application, because as Karl said, the Sling feature model it's in the Sling project, but it is really a pure OSGi piece of technology. So, I'm using OSGi to build my application. I got some bundles, it's going great. Some configuration for those bundles, config admin, everybody loves it. Add another bundle, some more bundles. My application starts to grow, it still works very well. Need some more configuration, some more bundles, and maybe some metadata as well, which is maybe, an SQL table creation script or something like that. So at this point, and this is actually still a fairly small picture, it kind of starts to become maybe a little bit hard to understand for someone who wasn't intimately involved in kind of creating this application. And obviously in this picture there's only like 7 bundles. In reality you can have hundreds of bundles with lots of configuration and lots of metadata. So it's basically hard to wrap your head around, maybe why is that bundle there, who is using that, I have hundreds of bundles here, is this bundle needed by anyone? So rather than having to understand all these individual bundles, the idea of the feature model is to wrap them all up in a feature, including their configuration and including all their metadata, and put a little bow on top, and then you have like a nice feature that is easier to understand and easier to deal with, especially with people who don't know your application so well as you might do yourself. And also, if you build a larger application, by grouping things in features, you kind of create another layer of modularity in your application, and it becomes easier to maintain for everybody. So you've got your feature for your application. Let's say you're building a web application or a web service. That web service needs a HTTP service, and it needs a JAX-RS service maybe, it needs a database connector. So these are all features that you can then kind of resolve or use from a repository like Maven. So rather than having to know exactly how they work, you just say, I want HTTP, I want XRS. Again, chunky bits put together, and then you give that to a feature model aggregator. And the feature model aggregator can create a distribution from it, which is basically what you can give to your customers. Now, whether this is a runnable application that your customers actually run themselves, or whether this is yet another feature that they can embed in their larger application, those are both possibilities. So this aggregation process, it serves two main purposes. First of all, if you use different features from different places, there is quite a high chance that there is overlap in terms of bundles that these features contain. For example, the chances are high that that there's more than one feature that uses the same logging service or something like that, or maybe the configuration admin service is kind of provided twice. So the aggregation process is there to eliminate duplicates and to basically merge these features together properly, so that you have no ambiguity anymore in what is actually being put in this final distribution. Another thing that they can do is they can analyze your features, and this is done. Well, there's a couple of reasons for it. For example, you may want to say this feature has to be runnable. So I don't want any missing dependencies. Like a feature on itself can have missing dependencies. Like this one here, for example, has probably a missing dependency on some database code, and that's fine. But when you want to actually run it, obviously all the dependencies have to be resolved. So these analyzers can check that for you ahead of time. So before you actually run your application, you already know that all the dependencies are there. And if they're not, you can use, for example, a Maven build. You can fail the build, right, if this is what you want to check. But analyzers can also check other things, that you're following coding practices, or that there's also something called API regions, which I don't get into too deeply here, but you can limit the public API that is visible to your to the users of your application if you have an extensible application, and you can basically have analyzers around that they are configured correctly. And you can also add in your own analyzers. And another thing that is worth mentioning is that since you can have metadata, extensible metadata in these feature models, you can also plug in your own mergers. So let's say your metadata is like an SQL creation script. If you have two of those, then there's probably a way to merge these into one script, right? So depending on the type of metadata, you have different merging mechanisms for this. And again, that can be plugged in here when the final feature. And this distribution is just another feature, right, when that is created. Okay, so now you've got your distribution, and you want to launch it. You've enabled the analyzer that says, I don't want any missing dependencies, so I know I can launch it. I can give it to the launcher. Launcher is a tool that Carl will talk about more later on. But it's as simple as that. You give your feature to the launcher, and there's your runtime, your system runs. Now, in some cases, there are things that you want to specify after you've created your feature model. And this is often configuration that is like database API keys, or maybe some host name of another system that you connect to. This is something that you really don't want to bake into your feature model. So the feature model also supports late binding variables, and you can pass these variables in on the command line, like an API key or a database host or whatever you want really. And so this is basically inserted in the configuration. And it kind of goes a little bit towards what I think Mark mentioned yesterday, Mark Hoffman, is that they sometimes create higher level configuration. So your config admin is very detailed and everything is kind of very finely specified. But when you really have a system that is running, you often only have to specify a handful of things and not every single value. So this is typically kind of this hooks into the same idea. These are kind of the high level things that you typically modify, whereas many of the other configurations that you use in your application will never change from one run to the other. Another thing you can do with the feature model is, let's say your application has a problem, Obviously, that never happens to everyone, but you know, for the people that do have this problem, you may want to be able to deploy a diagnostic tool as part of your launch. So this is also possible with the feature model. You can give the launcher more than one feature, and the launcher will aggregate these on the fly before they're kind of run. So in this case, if I want to diagnose a particular issue, I can add the web console, provide that to the launcher as well, and then the web console will be available in my runtime, and I can diagnose my system. So that, in a nutshell, is kind of the life cycle of the feature model. And then here I have a quick slide about what in Sling, what is the feature model world, what we have there. And we have 5 main components: the feature model API, there's a serializer to JSON, there are the analyzers, there's the launcher, and then there's the tooling. Currently, this is primarily Maven tooling through the Sling Feature Maven plugin that provides most of that functionality. Excuse me. And then there are some smaller additional components. For example, there's a component that generates a feature that represents the current runtime. If you want to see what the runtime is and probably want to freeze dry that and be able to run it again, you can use that to generate a feature of a runtime. There's a web console integration. There's a diff tool that basically can tell you if you've launched this runtime, and actually at runtime you make changes, maybe you tweak some configurations. This diff tool can basically tell you exactly what you changed there. And then you can use that if you want to keep those changes. You can use that to create a new feature model. And all of this is comes out of the one of the main principles behind the feature model is that it should really work for immutable deployments, which is what a lot of people use in Docker contexts. So rather than really changing a runtime, you want to basically start a new Docker container if you have changes in your configuration, so that everything is immutable. But during development, this can be handy to capture what you've changed if you were tweaking certain things. So that's why this tool could be useful. There's also a carafe converter, one of the other tools where basically convert your feature into a carafe feature. And then there's some components around this API region stuff that I mentioned earlier. If you have an extensible platform that you give to your users, but you don't want your users to use all of the internal APIs that you might be using yourself. Right? So let's say you have a dependency on some Apache Commons libraries that you just use because you're using them. You don't necessarily want your customers or your end users to use the same Apache Commons libraries, because you may want to change them later on in a refactoring, or maybe they want to use their own version of those. So this API region stuff is a way to separate those so that users can use their own, whatever they want, whatever version they want, and also you're not obliged to maintain compatibility in terms of internal dependencies that you might have on your platform. Okay, so here's a really quick example of what a feature model looks like in JSON. In theory, you can also use other serializations, but I think JSON is what we're settling on at the moment. It has an ID. This one is called OSGi HTTP. This one has one variable. You can set the port. The default to 8080, so if you don't specify that, you get 8080. Here we only have 2 bundles, but obviously it could be a long list, and 1 configuration. So the configuration follows the OSGi configurator syntax, so that's already an OSGi spec. This part here can have many configurations there. And the bit that I didn't show in this example here is that there's also custom extensions, so you can put some your SQL schema in there verbatim, right? So whatever you want can be either text, JSON, or artifacts, like this is examples of artifacts. And they can all be part of the feature model. So you have one file, one model that encapsulates all. Okay, and then the final thing before I hand it over to Carl to briefly mention is the tooling. The Sling Feature Maven plugin, it has many different pieces of functionality. It's a Maven tool with many goals, and you can use those goals in wherever you see them fit. But I lifted out 3 important ones. The aggregation, so you can say, I want a new feature to be generated from these other features, and it could be many other features. And so this can be used to create runnable features. It can merge your extensions, so you can plug into this process. And so this is a way to create larger features from smaller ones. The analyzers, there are a bunch built in. You can also add your own. They can check that the imports and exports, the imports are all covered by available exports in all your feature models, that all the requirements in there are covered by capabilities in your feature models. And one thing to mention is that the imports and exports and requirements and capabilities are automatically inherited from all the bundles that are referenced by your features, but you can also add them into the feature model itself. So, for example, a feature model could reference a number of bundles, and together they provide an implementation of a particular extender, right? So individually they don't, but together they provide this. So you can make a feature model provide additional capabilities by itself. There's an OSGi Connect checker, which is, well, basically it checks that your feature model works well with OSGi Connect, which is where you don't really have class hiding, and the class loader is left up to the surrounding platform, and there are API region-based analyzers as well. And then there is another really useful one that creates a repository of all your artifacts. So if you have a feature model and you want to create a Docker image from this, then you don't want that Docker image to have to go out to a Maven repository to get all the artifacts when it's being run. No, you want all those artifacts in that Docker image. So with this goal in the tooling, you can basically say, okay, this is my feature model. Give me everything that it needs, put it in a Maven structure. It's just a directory structure. So you can actually put that in your Docker image and run your Docker image without the need for any external repository. And with that, I'd like to hand it over to Carl again.
Right. So, and just to get that out there, I mean, I think there's really 2 parts to this. So on the one hand, we have the feature model files, or the specification of how they look like, right? And the hope there is, and David mentioned it in passing, but there's a part he didn't really show it. It's an extension, so you can add your own kind of extensions into those feature models, right? So if you have things that you want to do or express which are not captured by the default or standard parts of it, you can make it your own by adding extra data, right? But other than so, and because part of the idea there is that if we could get this eventually spec'd by the OSGi Alliance, obviously there is already things out there which are trying to do similar things, right? We mentioned Apache Graph features. That's one instance. Obviously here in this context, it's P2, which did a lot in this area. We had back in the day with Luminous, we had similar things done. So it's not a new problem. It's a new solution obviously to it, but it's not one that is necessarily adding that much on top of it, right? But the hope is that we can use it at least in parts as a standard base for maybe other tools in that area as well, because if they could start using that as a kind of an interchange format for these kind of information, you know, and nowadays you even have BND tools, which again has a similar repository structure on disk. And if you could standardize on that and have tools that need extra information do that via extensions, then I think we could collectively gain something by understanding what you want to share, right? So that said, I mean, for the Sling part of it, we try, as David also mentioned, to create an implementation on top of it, which is geared towards immutable deployments in Docker and so simple things, not necessarily changing or maintaining a framework at runtime, but just setting it up and starting it up. And so we have a launcher for that. It is very simple in that it mostly it allows you to select the framework you want to use, give variables and framework properties that are open, as David showed, and then just it allows you to merge some features late if you didn't pre-merge them with some tooling. And handles artifacts by effectively just understanding Maven repositories, right? So you give it a couple of features, it will find the artifacts in it and look for the local and remote Maven repositories you give it, and get the artifacts from there and start it up. And for the extension handling, as we mentioned, if you give extensions in the feature files that we don't understand, you can provide plugins to handle those during the startup time. And so for the how to use the Sling tooling there in practice, I'm going to quickly give a little bit of a demo. It's using the Maven plugins to create the repositories of the artifacts that you need, including the framework and the extensions. The code will be available, and then creates a Docker image, which is based on Java 11 in this case, and J-links it together so it needs a minimal set of dependencies, and then uses the Sling Feature Launcher to start a demo app, and it shows a little bit, and that might be not what we get into today, but how you can use a Felix config admin in memory and some extensions to it. And finally, I have a demo of how you can use that mechanism to layer Docker images and use that to layer the feature models as well in this setup. Let me try to get out of here then. Okay, that didn't work. Okay, and show. And I think I can turn this on. Hello? Yeah, that should hopefully work. Okay, so I'm using the demo I gave yesterday with Radu Codescu as a basis here. So this is a little bit how the demo was created. So let's say we have, you don't need to understand all of it, but let's say we have a reasonable, simple base bundle or system that we want to have. It's a resource provider for Sling. And what the bundle does is it connects us to remote sources, but that's not important. The important thing is we can give in our project here in the source main feature folder, we just create a feature.json which describes our base feature, right? So it references the bundle that will be built by this project down here, and a couple of the dependencies or the main dependencies that bundle will need to run at runtime, right? So that's like a base feature. So and the benefit is if you want to use that bundle here that gets created in the project, well, you already get the dependencies it has, right? And then for making that a feature model aware project, all you need to do is to add the Sling Feature Maven plugin to your POM and say, okay, attach features. So that will then look at the feature, process it, and attach it as a Maven artifact together with the main bundle that we built here. So after we did that, we now have a second project, the resource provider Dropbox, which is an implementation of the first one for connecting us to Dropbox. Again, that specifies a feature file here for its own bundle and 2 extra dependencies it has on the Dropbox SDK and on some additional library, right? So we again, in that case, we just use the Sling Feature Maven plugin in our Maven project here to have it attach the feature again, that's down here, but as on top we aggregate our feature that we built in this project, that's the file includes here, together with the other feature that we built before in the resource provider. So what that does is that after this aggregate has run, we end up with a merged feature of the two, so that we can start them together in one referenced feature. Okay, so with that setup, we look at a little bit of a Sling mini project, which is the minimal Sling features for a minimal Sling. You know, So that's in this feature file here. It has a little bit, has more bundles because that is getting in the complete base Sling system, and that entails the minimal OSGi runtime. So you see event admin is here, meta type is there, config admin is there. But again, main part is after somebody did the work to find out what bundles are needed, you don't have to care about it. And we give one configuration in it, which is needed to get Sling to start, and some framework properties that we need for Sling as well. And that's the base system. We define 2 extra ones, JDK extras, which just grab some Geronimo specs and the web console, so that we have a feature available for the web console if we want it, as David showed in his demo and in his slides, that you can kind of side merge it if you want to do some analytics. And then we have the POM again. Again, we have an aggregate features, which will just aggregate the features together. We have an attach to attach it. And we have another extra goal, which is called create repository. Called the repository goal of the Sling Feature Maven plugin. This one you can give a classifier or a reference to a feature file at any rate, and it will go in and find all artifacts and dump them into a local repository. Right, so this creates us a Maven repository with all the artifacts we need. We will use that in a moment because we also have a Docker file in here, and we set up the Docker Maven plugin to create us a Docker image out of it. So the Docker file is reasonably simple, uses Alpine and J-links together a minimal JDK runtime that we want to have. And then it effectively mostly just copies this artifacts directory that we created, which has all the required artifacts from the feature models, into the Docker image and the launcher and the feature itself that we want to run. And here it just gives the command to run the feature launcher, the Sling Feature Launcher, points it to the local repository to find its artifacts, and gives it the feature to launch. So that's the setup for the Docker image here. And the nice thing is, again, when you think about how you wanted to use that to create your own Docker images, well, if you have a remote feature from somebody that you want to run, you just point this Maven plugin to the feature, it generates you the repository for that with all the artifacts that you need, and you wrap it in a Docker image, and then you have something you can start. Right? And it all works via Maven in this case. And then just to wrap it up real quickly here, we have the mini demo, which is an extension of what we just had. It effectively adds one more feature for the Dropbox variable, for the access token that you need to run it, that feeds it back into a configuration that is needed at runtime. So it's a feature again. And then just adds the Dropbox resource provider in another feature on top of the other things and dependencies. Again, we then in the POM of that one aggregate the features together and create a new repository, which will now only include the dependencies of this mini demo, the extra ones. We have a new Docker file, which can in this case even inherit from the one we created before. So all it needs to do on top of the one that we already had on the layer before is to add the artifacts that are extra in this mini demo and copy the feature that we want to use in this case, so the extended feature into it. So we have a nice symmetry between the two projects, right? Because we had the Sling Mini, which creates the runtime and all the artifacts needed for running Sling, and now we have kind of an extension project which just defines what we want to run on top of that in terms of features, but also in terms of Docker image, right? So it's a parallel setup for the layers. So with that, I can create the images. Well, I mean, I don't think it's super interesting to show the build. So I mean, we end up with two Docker images, a Sling Mini and a Sling Mini demo. As you can see, the one is 65 megabytes, the other one is 74. That's because we layered this one additional thing on top. And well, I can run it. It's not gonna right. Not gonna tell you too much. It just starts Sling and the things we have in there, and the web console in this case that's included as well. So hopefully this works. Yeah. So we got a working Sling with the web console and 53 bundles in total out of the feature model. So, and yeah, I could show that that we now can do the second layer as well if you wanted to, but I think we're running out of time quickly, and you just have to believe that I could if I wanted to. No, I shouldn't have done it from the start, but okay, let me get back to the slides. Right, so in case you wanted to try it out yourself, that's all available on GitHub. The link is here in the Sling whiteboard, so you can find those projects there and try it for yourself. And with that, we almost done, but David is going to tell us a little bit about where we are inside the Alliance with that we got.
Okay. So yeah, just before I get into that, I think it's pretty cool that we have like a Docker image that it contains Java and Sling with only 65 megabytes. I know Java is even focusing on making Java smaller. That'll have a big impact on that as well, but it's already really small for a Docker image, right? And so that's very cool, and you can try that all at home with the link that was in there. Just really briefly before we go into questions, so yeah, we're basically proposing this in the OSGi Alliance as a specification so that there is a portable standard for defining feature models that will hopefully be a way to interchange between Karaf and Eclipse and Sling and maybe there's a lot of companies that have similar mechanisms as well, and so that should give us a portable kind of interchange format. There was an RFP. An RFP is like a requirements document in OSGi that has been accepted already, and currently we're working on the technical design in RFC 241. And you can see it there. And also, if you have any feedback or any thoughts, this GitHub repository contains information on how to provide that. So that's the only thing I wanted to add. Oh yeah, and also some links to Sling itself, where you can find the current implementation that we talked about. And with that, we have a few minutes for questions. Anyone? Any questions? Udo. Right. So the question is there any integration with BND? The integration of the tooling, BND is a tool. At the moment is in the Sling world, it's on the Maven level. Now BND is integrated with Maven as well, so we use BND and this tooling in the same POMs. We use BND to create bundles, and we use the Sling Feature Maven plugin to create the features. But that is just one tool setup. I mean, it's not required to do it this way, but that's the way it currently is. So they work together. They're not integrated, but they work together as providing separate pieces of functionality into one tool chain.
Yeah, could get a viable BND launch configuration. Would I have to use?
Right, so that's a really good point. The BND launch configurations are also somewhat similar to feature models. So I think, and this does not exist yet, but I think it would be very possible that, given the OSGi specification, the BND tool, there could be a tool that turns a feature model into a BND launch specification for launching it. And then you would have an alternative launcher, right? So Carl showed the launcher that we have at Sling, but then you could use BND as a launcher. Yeah, this tooling does not exist yet, just yet.
Unfortunately, it doesn't exist yet, but obviously the hope is that it will be eventually natively supported by BND, maybe even. But yeah, I mean that is the goal of the whole endeavor, at least of that part of it, right? We have, as I said, we have two things. One is tooling for Sling because we have a vision of how we want to use it in Sling, but we also want, that's the other vision part, that this is the interchange format, right? And then yeah, exactly that is what is needed for other tools as well, but you want to be able to say, well, yeah, if I want to use it with BND or with P2 or whatever, I can do. And we do for Karaf. We have some tooling for Karaf already, but yes, BND would be nice.
And I think with that, we're out of time. Can we do one more question?
Yeah.
Quick one.
Since you're basically using Maven, the program, Maven dependencies, if you end up on the right part of the feature model, so how do you tackle that? Is there a kind of
Do you want to
generating the feature part in Maven dependencies, or?
We started with some integration there that you can at least skip the creating a feature altogether and just add the Maven plugin to generate your one wrapper around your current project, because that's a common use case. Yes, there is the parallelism of the Maven dependencies and the feature dependencies. But right now we don't have a way to say, well, package all dependencies into a feature. We do it the other way around. The dependencies you give in a feature will be attached to the current running project. So that side we do. And again, we have a goal for just saying wrap everything into into a feature, but we don't have yet a way to say, well, we take the dependencies of the feature and put it into the feature model, which is something that you could consider. I agree. It is.
But you don't have to define them twice, right? So if you put a dependency in your feature model, they become part of the Maven project dependencies.
But the other way around makes some sense in some scenarios too. It's a little bit of a tricky thing because the build might not be the same as what you need in runtime, right? So but as an option, I would definitely support it to have something in that area.
Okay, thank you very much.